Hello, welcome back once again. Today we have this interesting limit, right? Limit as x is approaching 0 of 2 all over x squared minus the inverse tangent of 2x divided by x cubed. So in this video, we're going to solve this problem, okay? So let's get started. Well, now we need to obtain a common denominator, okay? So how exactly are we going to do that? Remember, we have 2 all over x squared, then minus the inverse tangent of 2x, then divided by x cubed. So this is going to be equal to, so the common denominator we're going to have here is x cubed, right? Because the LCM of x squared and x cubed is x cubed. Now x cubed divided by x squared will give us x, then x times this 2 will give us 2x, then minus, so x cubed divided by x cubed is 1. 1 times the inverse tangent of 2x will give us just the inverse tangent of 2x, right? So now, our limit is same as evaluating the limit as x is approaching 0 of 2x minus the inverse tangent of 2x, then divided by x cubed, right? Okay, so let's make the following substitution. So we're going to let 2x equals y. So solve for x in terms of y, we'll get x is equal to y all over 2. Now our limit is same as limit as, we are in the y word now, right? So no more in the x word. So here we're going to have y is approaching. So let's see what y is approaching as is approaching 0. So we know y is approaching 2 times x, and if x is approaching 0, y is also approaching 0. So here 2x is same as y minus the inverse of 2x is same as the inverse, the tan inverse or the inverse tangent of y, then divided by x cubed will be y over 2 whole cubed. So this is going to be equal to limit as y is approaching 0. So here we have y minus the inverse tangent of y, then divided by, so y cubed is y cubed, then divided by 2 cubed will give us 8, right? So we know this fraction at the bottom is going to flip, right? So that is going to be equal to 8 multiplied by the limit as y is approaching 0. So now we have y minus the inverse tangent of y, right? Then divided by y cubed. So this is what we have. Now we're going to use the Taylor series expansion for the inverse tangent, right? So here we're going to make use of it. So we know that the inverse tangent of y is equal to, so that is equal to y minus y cubed over 3, right? Then plus, is that y cubed? Yes, so plus y to the power of 5 divided by 5 minus y to the power of 7 divided by 7 plus, and so on. So in our limit now, this is equal to limit as y is approaching 0, right? So don't forget the 8 outside. So this is going to be y minus, so then the power series, y minus y cubed over 3 plus y to the power of 5 over 5 minus y to the power of 7 over 7 plus, and so on, right? Then everything is divided by y to the power of 3. So now we know that opening the bracket, the signs will change, and we know very well that, I think the signs have changed. Yes, okay. So we know very well that this y and this y will vanish. So this is equal to 8 multiplied by the limit as y is approaching 0. So we're going to have, we know this is y cubed over 3, right? So y cubed all over 3, and then minus y to the power of 5 all over 5 plus, and so on. So we're dividing everything by y to the power of 3. So we can see when we split the denominator, we know the first term here, y cubed over 3 divided by y cubed will give us 1 over 3, right? So this is going to be equal to 8 multiplied by the limit as y is approaching 0. So here y cubed over 3 divided by y cubed to give us 1 over 3. Then minus y to the power of 5 over 5 divided by y cubed, that will give us y squared all over 5, then plus, and so on. So now we can take the limits now. As y is approaching 0, all we have is 8 multiplied by, so 1 over 3 minus 0 plus 0 minus 0 plus, and so on, which is equal to 8 all over 3. And this right over here is the correct answer to the limits. Thank you for watching. Please, if you really enjoyed this video, please kindly support the channel by subscribing. Please do not forget to subscribe to the channel. Also like, comment, and share.